Some places are so extreme that building anything there should be impossible. The altitude kills. The cold shatters steel. The ocean floor shifts beneath your foundation. Engineers built there anyway. From military bases where the air is too thin to breathe to airports constructed on open water. Here are 10 structures built in impossible locations. Number 10. Chand Baori Stepwell, 800 AD to present. Chand Baori in Rajasthan, India, drops 13 stories into the earth with 3,500 steps arranged in perfect geometric symmetry. It's one of the deepest stepwells ever constructed, built around 800 AD during the reign of King Chanda of the Nikumv dynasty. Before stepwells, communities in this region relied on seasonal rivers that ran dry for half the year. The problem was reaching groundwater at depths traditional wells couldn't access, roughly 30 meters down through solid bedrock. Chand Baori solved this by creating a massive inverted pyramid carved directly into rock using hand tools. The steps descend in a double flight pattern, allowing thousands to access water simultaneously as the waterline receded during dry seasons. The geometric design created constant shade, keeping the structure 5 to 6 degrees Celsius cooler than surface temperatures that regularly exceed 45 degrees. There are limits, though. The structure requires continuous maintenance to prevent collapse, and modern pumping technology has made it obsolete for actual water access. More than 1,200 years later, this structure still stands, 13 stories deep, carved with hand tools, providing access to water in one of the driest regions on Earth. Number 9. Gwadar Port, 2002 to present. Gwadar Port sits on Pakistan's southwestern coast, where there was no fresh water, no roads, no power, and summer temperatures exceed 45 degrees Celsius. Building a deep-sea port here meant constructing the entire supply chain first. Developed beginning in 2002 through a Pakistan-China partnership, Gwadar offered the shortest shipping route from the Arabian Sea to western China, potentially cutting 12,000 kilometers off existing routes. But every ton of concrete, steel, and equipment had to be transported hundreds of kilometers through desert. Engineers built in stages, roads first, then desalination plants for fresh water, then worker housing and power generation. Only after this infrastructure existed could port construction begin. They dredged shipping channels and built breakwaters to protect against Arabian Sea storms. By 2016, the port could accommodate ships exceeding 50,000 tons. Maritime engineering studies document construction costs were 40% higher than comparable ports due to logistics. There are some limitations, though. The isolation remains a challenge, and regional security concerns have slowed expansion. A deep-water port now operates where there were no roads, no power, and no water 25 years ago. That's what building in an impossible location looks like when strategic value justifies the cost. Number 8. Tiger's Nest Monastery, 1692 to present. Taktsang Monastery hangs from a vertical granite cliff 900 meters above Bhutan's Paro Valley. The monastery appears to defy gravity, accessible only by a narrow trail where a misstep means a 900-meter fall. Constructed in 1692, though the site had been used for meditation since the 8th century, the monastery required workers to scale sheer rock using ropes. Every stone and timber beam had to be carried up on human backs, or lifted using wooden pulleys. Engineers carved chambers directly into the granite, then extended wooden structures outward from these caves. The monastery essentially hangs from the mountain, supported by timber beams driven into rock crevices. Construction took decades. In 1998, a fire destroyed much of the wooden construction. Restoration required helicopters to transport materials, something original builders accomplished using only ropes and pulleys. There are limits, though. The monastery can accommodate only a small number of monks, and expansion is impossible due to the vertical terrain. A temple complex hangs from a cliff where conventional construction should be impossible. More than 300 years later, it remains, proof that spiritual motivation can overcome apparently insurmountable physical constraints. Number 7. Burj Al Arab, 1994 to 1999. The Burj Al Arab stands 321 meters tall on an artificial island 280 meters offshore from Dubai. Before 1994, there was just open water above a sandy seafloor 11 meters below the surface. Designed by British architect Tom Wright, the sail-shaped hotel required creating stable ground in an active marine environment. The seafloor was loose sand that shifts with currents. You can't anchor a skyscraper to material that moves. Engineers drove 250 concrete piles, each 40 meters deep, through sand into bedrock below the seafloor. They surrounded these with thousands of tons of rock, creating a 9,000 square meter island connected to shore by a 280-meter bridge. The building's steel exoskeleton flexes during high winds. Dubai experiences shamals with gusts exceeding 100 kilometers per hour. The sail shape reduces wind resistance. Engineering studies show the island has settled less than 2 centimeters since 1999. There are some limitations, though. The island requires ongoing maintenance to prevent erosion, and the isolated location complicates emergency evacuation. An entire island and a 321-meter hotel now exist where there was only water 30 years ago. Impossible location often just means expensive location when economics justify it. Number 6. Lærdalstunnelen, 1995 to 2000. Lærdal Tunnel in Norway stretches 24.51 kilometers through solid rock beneath 1,600-meter mountains. Before this tunnel, the route required driving over passes closed by snow 4 to 6 months annually. Constructed between 1995 and 2000, the challenge was geological and psychological. The route passed through unstable rock with high groundwater pressure. Research showed drivers in long tunnels experienced dangerous fatigue after about 20 kilometers. Engineers removed 2.5 million cubic meters of rock, reinforcing walls with 45,000 rock bolts and 200,000 cubic meters of sprayed concrete. They solved the psychological problem by creating 3 large mountain halls, illuminated caverns with blue and yellow lighting that simulate open sky, breaking up the monotony every 6 kilometers. The tunnel opened in November 2000, carrying more than 1,000 vehicles daily. Travel time dropped from an unreliable seasonal route to a consistent 20-minute drive. There are limits, though. The ventilation system requires continuous operation, and maintenance involves periodic closures. 24.5 kilometers of tunnel now connect 2 valleys that were seasonally isolated for centuries. That's building in an impossible location, when the only way forward is straight through the mountain. Number 5. Trans-Siberian Railway, 1891 to 1916. The Trans-Siberian Railway spans 9,289 kilometers from Moscow to Vladivostok, with roughly 40% crossing permafrost, ground that thaws and refreezes seasonally, causing anything built on it to shift and fail. Construction began in 1891 under Tsar Alexander III. Russian engineers faced temperatures from 40 degrees Celsius in summer to minus 50 degrees in winter. The fundamental problem: permafrost behaves like bedrock when frozen but becomes unstable mud when thawed. Engineers built elevated roadbeds using gravel and crushed rock, raising tracks above the permafrost layer. Where this wasn't possible, they used timber piling driven deep into frozen ground. Construction required more than 90,000 workers at peak. Records from Russian state archives document more than 35,000 workers died from disease, accidents, and exposure. The project took 25 years, completing in 1916. The railway still requires continuous maintenance to address shifting ground, with seasonal speed restrictions in unstable sections. More than a century later, this railway still carries passengers and freight across terrain where the ground itself cannot be trusted. It remains one of the most ambitious infrastructure projects ever completed in conditions that should make permanent construction impossible. Number 4. Halley Research Station, 2013 to present. Halley 6 Research Station in Antarctica sits on a floating ice shelf that drifts toward the ocean at 400 meters per year. Temperatures drop to -55 degrees Celsius. Winds exceed 160 kilometers per hour, and the sun doesn't rise for 105 consecutive days. Built between 2006 and 2013, Halley 6 replaced 5 previous stations that were crushed by ice accumulation or drifted dangerously close to the shelf edge. The problem? Antarctica's ice compresses, cracks, and moves. Fixed structures eventually fail. Halley 6 solved this by mounting the entire facility on hydraulic legs with retractable skis. The 8 interconnected modules can be towed to new locations when ice conditions become dangerous. In 2017, when a major crack formed in the ice shelf, engineers relocated the entire station 23 kilometers inland. The station accommodates up to 70 researchers in summer and 16 in winter. Power comes from wind turbines and diesel generators. There are some limitations, though. Relocation is only possible during summer, and winter evacuation is essentially impossible. A research station now operates on floating ice that moves toward the ocean every year. And when the ice threatens it, the entire station relocates. That's building in an impossible location while accepting that the location itself is temporary. Number 3. Channel Tunnel, 1988 to 1994. The Channel Tunnel runs 50.5 kilometers beneath the English Channel, with 38 kilometers underwater through chalk marl 40 meters below the seabed. Constructing it meant drilling 3 parallel tunnels through unstable geology while maintaining precision alignment. Built between 1988 and 1994 by 13,000 workers, the tunnel used 11 massive boring machines operating from both English and French sides. The problem? Chalk marl is stable when dry, but becomes plastic when saturated with water. Groundwater seeped continuously, requiring pumping systems removing up to 1,000 liters per second. When the tunnels met on December 1, 1990, alignment was off by just 358 millimeters horizontally and 58 millimeters vertically. Remarkable precision across 25 kilometers from each direction. The tunnel opened in 1994 and now carries approximately 11 million passengers annually. Travel time between London and Paris dropped from 7 hours to 2 hours 15 minutes. There are limits, though. The tunnel is vulnerable to fire, and any major geological shift could compromise the structure. 50 kilometers of tunnel now connect 2 islands separated for 450,000 years, and trains pass through every few minutes, carrying passengers who probably don't think twice about traveling underwater. Number 2. Hong Kong International Airport, 1992 to 1998. Hong Kong International Airport sits on a 1,248-hectare artificial island that didn't exist before 1992. Engineers leveled 2 mountains, reclaimed 9.38 square kilometers from the South China Sea, and built the world's largest airport terminal, all in 6 years, during typhoon seasons bringing 10-meter waves and 150 kilometers per hour winds. The problem? Hong Kong had no available land. The solution was creating it. Engineers flattened Chek Lap Kok and Lam Chau Islands, removing the top 100 meters, then deposited 350 million cubic meters of fill into the ocean. Seawalls used concrete blocks, weighing up to 25 tons each. The two 3,800-meter runways required surfaces level to within millimeters. Construction employed more than 21,000 workers, operating 24 hours daily. The entire project, airport, highway, rail link, and bridges, was completed in 1998 at $20 billion. The airport opened July 6, 1998, handling 28 million passengers its first year. By 2024, that exceeded 70 million annually. The island has settled just 1.2 centimeters, well within predictions. There are some limitations, though. Expansion is constrained by the island's fixed size, and severe typhoons still force temporary closures. An entire island, an airport handling 70 million passengers annually, and complete infrastructure, all built in 6 years in open ocean. Yeah, that would be pretty impressive under any circumstances. Number 1. Siachen Glacier Military Bases, 1984 to present. At altitudes between 5,400 and 6,700 meters on the Siachen Glacier, Indian and Pakistani forces maintain the highest altitude military bases on Earth. Temperatures drop to -50 degrees Celsius. The air contains half the oxygen available at sea level. Avalanches occur daily. This isn't just impossible for construction. It's barely compatible with human survival. The glacier became militarized in April 1984, when Indian forces preemptively occupied it during Operation Meghdoot. Both nations established bases not for strategic value, but because allowing the opponent control was politically unacceptable. At these altitudes, humans develop acute mountain sickness within hours. Supplies must be airlifted by helicopters operating at performance limits. Bases are prefabricated modules with triple-layered walls and heating systems running 24/7. Turning them off for hours in winter would be fatal. Military medical journals document that 97% of casualties are from altitude illness, frostbite, or avalanches. Between 1984 and 2020, more than 4,000 soldiers from both nations died on the glacier. An average of 1 soldier dies every other day, most from environmental causes. I'm sure you've seen the footage. Soldiers in bunkers carved into ice, supply convoys on slopes where avalanches are routine, helicopters attempting landings where rotor strikes mean fatal crashes. There are limits to what's operationally possible. During worst winter months, helicopter resupply becomes too dangerous. Both nations acknowledge the cost is unsustainable, yet neither will withdraw. Military bases operate at 20,000 feet, where human physiology fails, where air is too thin for helicopters to fly reliably, where avalanches kill more soldiers than enemy fire. Few places on Earth are more hostile to construction or habitation. Yet soldiers and engineers remain, maintaining positions that exist only because withdrawal is politically impossible. And that is building in an impossible location, where impossible doesn't mean difficult or expensive. It means lethal.